All right, now that we've translated expressions, there's some other things that we need to do as well. And one of the important things is evaluate. So we're going to add some more words to our word wall and our knowledge of algebra with our new vocabulary. So evaluate means to come up with a value or one number. The hard thing about algebra is you'll see in the directions that they change. So there'll be things that'll say simplify, and then there'll be just some algebraic stuff. There'll be some that say solve. There'll be some that say evaluate. And a lot of times students read that and aren't sure what that's all about. Well, each of those verbs means something a little bit different. So we're going to focus today on evaluate, but there also is the idea of simplify. And simplifying is something that we're going to be concentrating on the next lesson, but I wanted to define the word here. Simplifying means basically to make simple, to make it as small and compact as possible. What you want to know, since mathematics is a model of the world, we do want to make sure that the math is tight and easy to understand. And if you're going to carry math into different parts of an equation, like we were doing when we plugged in our variables and we put them all in one variable, like when we did perimeter and when we did our calculating the angles, measures, etc. When we did that on our translating sheet, what happened was those expressions were ridiculously long. And when that can be more simple if you learn to simplify. And you can make that expression pretty tight, and then it becomes easier to solve or come up with one answer or solution. But in this case, simplify just means to collapse it down. So if you can add anything, add it. If you can multiply anything, multiply. If there's parentheses, if there's a way to use distributive property to get rid of the parentheses, then by all means do that. But that's the whole point of simplifying, is to get it down to the most simple way to solve. And simplifying in a lot of cases was the stuff we were doing in translation, where we were putting them in terms of one variable, and then we'd have to continue to simplify. There's also something called combining like terms, and that'll happen in our next lesson as well with algebra tiles, and you'll be able to see how we do combine like terms, but that is another form of simplifying. Today though, we are going to focus on evaluate, and the word value is what the trick is in there, that it's going to come up with a number, a value when you're finished. That's when people say, well, am I solving this? Or, well, solving can kind of mean that, but in this case, when we say evaluate, we mean for one number. So to come up with a value or a number. And I have an example on here when I evaluate an expression and I tell you what I want x to be or the variable to be, all you have to do is plug it in. And we do that using the property of substitution. So some simple ones that we're going to start out with. So for instance, we're going to evaluate, our directions are to evaluate for x equal to 2, y equal to -1, and z equal to 3. These are the values given, and if you sometimes wonder, well, why? In this case, it's just a practice. They have to be given to you, but in some cases, the values are given to you by the nature of the problem, so it changes per problem. In this case, though, I'm going to come up with a couple examples. So for instance, I have 3x minus 2y, and I want to evaluate that. I'm going to do x over y plus 2z. And you can do all different kinds. You can make it as elaborate as you want to. You can do x to the second plus 3y minus 4z. So we can make these pretty complicated, and they look really complicated, but really when we talk about how this gets solved, it's not that difficult. So when we say evaluate for x equals 2, substitution property, and you probably already looked at substitution, but just a little refresher. When you substitute something, that means you take one thing that is exactly the same as another and reverse them.
For instance, in football, if one player comes in and takes the spot of another player that is playing the exact same position, that's a substitution property. So here player 2 is going in for player 4 in the exact same position. That's substitution. It happens in the world, it happens in math.
The same thing's going to happen here in mathematics when I substitute. When I say x is 2, in this case, when I'm evaluating, that means the 2 is going to go in for x. Now, we have 3 sitting next to the x. I told you before that even when you sit them next to, you sit a constant next to a variable without putting any operation in between, you mean multiplication. That's kind of challenging and sort of new, so you have to get used to that. So this is really 3 times 2 minus, and then we have our y
equal to -1.
So what it's going to be careful, you have to really watch. The challenge in evaluating is the positive and negative situation. You also have to watch order of operations. So I'm going to put -2, and then it's times, because 2 and y were sitting next to each other, so it's really -2 times -1. Now, depending on what you've been taught with positives and negatives, you have to follow along with what you know. I know my 3 times 2 is 6, and that's because multiplication comes before subtraction. So I have to watch my order of operations. I am going to keep my subtraction sign, but I also know that 2 times -1, the multiplication is going to come first. So 2 times -1 is -2. I'm just going to put parentheses there to remind myself that that negative goes with the 2. So this problem is 6 minus -2. Well, the opposite of subtraction is addition. If I want to take the opposite of negative, that's positive. So that's going to become 6 plus +2, or 8. If I can also say 6 take away a -2, if I was on the number line, if I'm at 6, let's see, I have 0, 4, 6, 8, I'll put a 2 in there. If I'm at 6, and I say take away a negative, I'm going to, first of all, take away is going this way, and a negative is going to flip me back around. I'm going to have to go up to 8. So be careful about the positives and negatives. Now, when we evaluate the next problem, once again, we're going to still substitute in our values. Let me grab a different color pen so we can see the colors going in there. So we're going to put in our x is 2. So it's going to be 2 divided by, and y was -1, plus, and remember when they're next to each other it's multiplication, 2 times, and z was 3. And notice I don't necessarily have to put the parentheses, but I do. You get used to different formats, especially when you see a book or a textbook will look different like that. All right, going back to our order of operations, you've got division, we've got multiplication. Division starting on the left-hand side will come first. So 2 divided by -1 is -2, plus our 2 times 3 is 6. When I add our -2 and a +6, remember there's 2 negative guys and 6 positive guys. A positive and a negative make a 0, +1 and -1 make a 0 pair. So there's our additive inverses, and I'm ending up with +4 because there were 4 left on the positive side. Now, with our inside this region, I'm going to still plug in because it was evaluated these numbers. So it's 2 squared, or 2 to the 2nd power, plus 3 times -1, putting it in there, remembering that that's times with the parentheses, minus 4 times 3. Watching our order of operations, what should come first? Parentheses, but this is multiplication inside. You look in the parentheses for parentheses, and nothing can be done to -1, it's -1, and nothing can be done to 3, it's just 3. The parentheses outside is the multiplication, and that comes after exponents, so exponents come first. 2 squared, or 2 to the 2nd power, is 2 times 2, so we have 4. Plus, now we're going to do our multiplication. There's 2 multiplications. We'll take the first one in line. 3 times -1, or the opposite of 3 sets, so it's -3. And then we have minus 4 times 3 is 12. All right, so if I do this work now, it's addition and subtraction. I'm going to do the first one in line, which is addition. So 4 plus -3, if I have 4 positives, 1, 2, 3, 4, and 3 negatives, a positive and a negative are an additive inverse pair, so those are 0, and they're gone. And I end up with a 1 left, minus a 12. So if this is a positive 1 and I have, lots and lots and lots of negatives left, one of them will cancel out, and I get 11 negatives. So it's -11 when I'm finished evaluating. All right, so I have a check for understanding and a homework sheet for you. There's a check for understanding that involves evaluating, coming down to one value. We also have some translating, so we're going to be taking some words and putting them into an expression or possibly an equation with an equal sign. And then there is an expression or equation and you need to translate it into words, some basic review, and then a processing section describing the difference between variable and constants. Also have up the answer key for the homework so you can take a look and see. But remember, there are multiple ways to write some of the problems and there's multiple ways to translate. So you want to make sure that you discuss as a group to see if anybody has a different way. The answer key is only one possible suggestion on some of the problems, whereas you might have a lot of different types of answers. Stay tuned and check out our next lesson. That lesson is on variables and constants, a little bit deeper, but it's on simplifying. So it's going to be working with algebra tiles. It's a very physical model for representing algebra.